This is the video for Secondary Math 2, the final exam review for pages 5 and 6. So on page 5, number 1, it says, write a congruent statement given these facts. So side BD is to FJ. Well, congruent statements comes from two separate triangles or two separate figures. So I just kind of drew my figures as I went. So I said, okay, so I have a triangle with side BD, so BD. And I have a triangle, that side corresponds to a different triangle where we have FJ. So do you see how they line up in the same spot? Now DG, so now we have a D to a G, that is corresponding to, or that's congruent to side JN, so JN. So I drew it down, and then GB, so that side is congruent to MF. So now I have my two triangles, and the congruent statement's really pretty easy. So we know triangle BDG is congruent to triangle, I said B first, so then F must come first. So F, and then I did D, so then it would be to J, and then down to G, so it would be to M. So there's my congruent statement. This is my answer here. Okay, so given this congruent statement, we're asked to answer these following questions, and these are actually the easiest ones. So angle Q is to what angle? Just use your congruent statement. Angle Q is to angle T. They sit in the same spot. So it must be angle T. RS, side RS is congruent to, must be UV. So UV, side UV. And then angle S, so angle S sits in the same spot as V, so angle V. And then QS, so that's QS is to TV. They just sit in the same spot. So really it should be easy given the congruent statement to go backwards here. So we have our answers. Okay, so it says prove the triangles are congruent if possible. So there's a couple different ways. Side, 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 angle, side, angle, side, side's not one. Remember that spells the bad word, angle, side, side. And then angle, side, angle is one. Okay, so given this information, we have three sides on this one, we have three sides on this one. We have one side on this, we have one side on this. We have two ticks on this, we have two ticks on this. So by side, 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 these must be, they must be congruent. Number 7, we're given a 1 tick mark, a 1 tick mark, 2 tick marks, 2 tick marks, and then we're given the same angle on each. So the order that this is given in was side, angle, side. So by side, angle, side, yes. Order matters, side, angle, side. And then on number 8, all right, so if we look at the order, we're given this information here. We have 2 ticks, 2 ticks, great. We have 1 tick, 1 tick, great. We have one angle in common, one angle in common, great. But the order it's given in is angle, side, side. So angle, side, side, which that spells the bad word. So in this one, we know that that's not a way of proving. It doesn't mean they're not similar necessarily. We just can't tell. Or it says not enough info. So not enough. There's not enough info on this one to be able to determine if they are or are not similar. Or congruent, sorry. And then we have these two triangles. We have one angle in common, one angle in common. 2 ticked angle, 2 ticked angle. So we have 2 angles in common, and then we have a side in common. And the order that we're given the information is angle, side, angle. And that is 1. So we have shown why these are congruent triangles using the correct way. Okay, so we're on number 10, 11, and 12. We're supposed to tell why the statements are true. So we're given this picture, and we're supposed to tell why by what, kind of theorem, or what do we know, given this picture, that for sure these angles are equal. So angle A is equal to angle C. Well, because we have these two parallel lines, we have a transversal here. That creates alternate interior angles. So we have this angle and this angle are equal because they're alternate interior angles. So alternate interior angles. So that's why number 10 is true. And then it also says angle AXB, so that would be that angle, is equal to angle CXD. So that would be that angle. Why are those angles equal? Because they're vertical angles. Those are vertical, they're straight across from each other, they're vertical angles. So So by what information do we know that this triangle is congruent to this triangle? So why are these two triangles congruent? And what information are we given? We're given an angle, then a side, then an angle. So it's going to be by angle, side, angle. So by angle, side, angle, we know that those are congruent. Number 13, we're given this information and we're asked to prove that this triangle is congruent to this triangle. So we're only given this information. First of all, that side LM is equal to NO. So this side is equal to this side. I drew it in. And then also we're given that angle LMO. LMO is this angle. It is equal to angle NON. So that's that angle. That's the only thing we're given. So looking at a picture, why in the heck are these two triangles congruent? Well, also, don't we know that this side is equal to that side itself? So let's look at the information, the order we're given it. Angle, or side, angle, side. Once again, side, angle, side. So we know that they are congruent by side, angle, side. So we couldn't insert anything besides what we were given into our picture, but obviously this side is equal to this side, so we were able to use that. So by side, angle, side, the triangles are congruent. Okay, so we're on page 6, we're asked to find on number 1, x and y. So the first thing we have to look at is what are we looking for? And we're actually looking for two angles of a triangle. So we know that all three angles of a triangle add up to be 180, and we know if we have an isosceles triangle, then the angles across from them will be the same. If sides are the same, their angles are the same. So if this side is across from 50, then this side's across from x, x must equal 50 degrees. So what we have is 50 degrees right there. And then all three angles better add up to be 180. So 180 minus 50 is 80. So y must equal 80 degrees. In this one, we're given all the sides. These are not angles. So we can't say that all three sides add up to be 180. That's not true. We only know angles, but we don't know anything about their angles besides that they're all equal. Well, if the angles are equal, the sides must be equal. So this side is equal to this side is equal to this side. So set up a true statement. 8 is equal to 2x minus 5. That's true. And also 8 is equal to y plus 3. That is true. Those side lengths are equal. Now just algebraically solve for x in each case. So I'm going to add 5 to both sides. So I have 13 is equal to 2x. 5 both sides by 2. So x is equal to 13 halves. All right, we just solved for x. And now to get y alone, subtract 3, 5 is equal to y. So y is equal to 5. So we just solved for x and y by setting up a true statement. Every picture is going to be different. You're going to have to set up a true statement depending on the picture you're given. Okay, in number 3 on pages 6. So on number 3 it says name a pair of overlapping congruent triangles in each diagram. State whether the triangles are congruent by side, 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 angle, 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 side, or HL. So, I redrew my two triangles. So first of all, hopefully you're able to see we have a right triangle right there. So I draw that in, that's triangle. Looks like I have a 90-degree angle right here. So at the top I have an A, then a D, then an E, and then the tick mark was up here. And then hopefully you're able to see that you also have this right triangle right here. So we have another right triangle. I'm going to draw it out as well. So I have another right triangle. It looks like my 90 degrees is right there. So I have a 90 degree, that's at E. And then we have our A at the top again. And we have our B out to the side. And then our tick marks right here. So then it's pretty easy to see that, you know, couple different things are happening here. You could use a couple different. First of all, I had a student notice that angle A is the same in both of them, and that makes sense. So by angle, side, angle, these triangles are congruent. Also, we could say by HL, which means hypotenuse leg. So because we have a hypotenuse and then one leg in common, a hypotenuse and one leg in common, we can say by HL that they are congruent. So you could use either or for this. And since we know they're congruent, we can now do a correct congruent statement. So ADE is congruent to AEB. Okay, in this next one, I redrew it. So once again, I have this right triangle right here. And so I redrew it, and that's triangle. It looks like WXY, and we have a tick mark right there. And then we also have this triangle right here. I was going to change colors. So we have this triangle right here as well. So I drew another one. And then that's 90, that's XWZ with a tick mark. And so it's easy to see that by HL, so that's, in this one, that's all we can use. So by HL, these are the same. Hypotenuse and leg, hypotenuse and leg, hypotenuse and leg. So we have a hypotenuse and leg in common, so by HL they're congruent. So then we can do triangle YXW is congruent to, stay consistent, get the congruent statement right, ZWX. So there we go. On number 5, these were kind of hard. You had to kind of use patty paper and kind of trace, move the patty paper around to figure out exactly what was happening here. So first of all, with this one, we want to figure out a congruent statement for the two figures and then write a congruent transformation that maps one onto the other. So first of all, a congruent statement would be like triangle. I'm going to just go with this one first. So HFJ. So HFJ is congruent to triangle. So H would be to C. And then F would be to, let's see here. That's kind of hard to tell. I would say that B is to, let's see here. I'm trying to decide here. What's longer? Let's see. 1, 2, 3. 1, 2, 3. Yeah. B is to G. So B is to G. So it would come after C would come A and then B. So this would be a congruent statement. Well, how did we get from one figure to the next? So the first thing is a reflection across the x-axis. If we reflect this top one across the x-axis, we're up 1, 2, 3, 4. Let's see, B goes down equally across the x-axis, so down 1, 2, 3, 4, so down 1, 2, 3, 4. If we reflect B, it's going to be right there. If we reflect A, it's going to be right there. If we reflect C, it's going to be right here. So now that it was a reflection across the x-axis. Now look, it looks almost right, but now we got to take each of those points and shift them up 1. So shift it up 1 over 1, 2, 3. See, up 1 over 1, 2, 3, we're there. Up 1 over 1, 2, 3. See, we're there. Up 1 over 1, 2, 3, we're there. So the answer would be a reflection on the x-axis. Then we shifted each one up 1 over 3. So this would be our final answer. And like I said, the really only way to figure this out is to sit and play with your patty paper. So just remember, with your patty paper, you draw in your figure. So I would have drawn this in. I would have also drawn in my x, y, so that when I start rotating it and flipping it, I will realign this up with this x, y axis here. Okay, so this next one, once again, you'll come up with a congruent statement, a correct one. So I said triangle FED is congruent to triangle QRP. And then I sat and played with my patty paper. So we actually take this object and we rotate it 90 degrees counterclockwise. So we're taking this object and we're rotating it with our patty paper 90 degrees counterclockwise. And if we do that, we'll end up not too far away. Just a second, I will draw that in for you. So if we took our patty paper and rotated it, we'd be here. I notice it's now in the right orientation. It looks like it's almost right. We've just got to shift those down 1, 2, 3 over 1 to the right, down 1, 2, 3 over 1 to the right, down 1, 2, 3 over 1 to the right, and we line up here. So we had a rotation of 90 degrees counterclockwise. And then we took it and shifted right 1. So we went right 1 and then down 3. So that's our shift. And really, once again, the best way to do that is to get your patty paper, draw in. I would have drawn in this original one. I would have drawn in my XY chart, and I would have started rotating it 90 degrees clockwise, 90 degrees counterclockwise, 180 degrees counterclockwise, 180 degrees clockwise. I would have sat and tested it. And once I rotated it 90 degrees counterclockwise, I was here and I said, oh, that looks like it's sitting in the right spot. Now I just have got to shift it down 3 to the right 1. So really it just takes trial and error. And that's all for this video for pages 5 and 6. Thank you for watching.